This is our first sum on compound gear train. So now we saw simple gear train and we are moving on to compound gear trains. In compound gear train, as you can see, B and C are the compounded gears. That is, both gears are on the same shaft. In this question, they have told us that A is the driver and E is the driven. They have told us that A is rotating at 1000 rpm. We just have to find out the speed and direction of E. So A is transmitting power and motion to B. B and C are on the same axis, so they are rotating at the same rpm. C is transmitting power to D and D is transmitting power to E. So we have to find out what will be the speed and direction of rotation of E. So I have already written the given data to find and the diagram over here. So we have to just find out the RPM of E and its direction. So we have been given the RPM of A and it is in the clockwise direction. A and B are meshing together, so we can find out the RPM of B. The formula, as always, RPM of B upon RPM of A is equal to number of teeth on A upon number of teeth on B. So RPM of B becomes NA into TA upon TB. NA is how much? 1000 into TA is 20 upon TB is how much? 15. So that gives us an RPM of 4000 upon 3. Let us keep it in this form only, numerator upon denominator. No problem if you convert it to decimal also, it will do. Okay. Now see, B and C are compound. Okay, first of all, this is rotating in the clockwise direction. A is rotating in clockwise, so B will rotate in anti-clockwise direction. A is in clockwise, so B will be in anti-clockwise. And B and C are compounded to each other. B and C are compounded. So if B is rotating in the anti-clockwise direction, C will also rotate in the anti-clockwise direction. Because of the anti-clockwise rotation of C, D will rotate in the clockwise direction. And because of the clockwise rotation of D, E will rotate in the anti-clockwise direction. So we know the direction of rotation of E. The direction of rotation is anti-clockwise. Now we just have to find out the magnitude. Okay. So B is rotating with an RPM of 4000 upon 3. Okay. B is compounded with C, that is they are on the same shaft. So the RPM of C will be same as the RPM of B, which is 4000 upon 3. Okay, you can always convert it into decimal, no problem. So C is meshed with D. C is meshed with D, external meshing. So N of D, RPM of D upon RPM of C is number of teeth on C upon number of teeth on D. So ND is equal to NC into TC upon TD. NC is what? 4000 upon 3 into TC is what? 30 upon TD. TD is what? 15. So this will cut 10. So it will be 4000 into 10 upon 15. 4000 into 10 upon 15. That will be 8000 upon 3. Okay. 8000 upon 3 RPM. You can convert it into decimal. I am just keeping it like this in a hope that it might get cancelled in the end. Okay, I don't know whether or not it will get cancelled, but just hoping for it. Okay, so the final we have to find out the RPM of E. To find out the RPM of E, again the same formula. See, D and E are meshing with each other. So RPM of E upon RPM of D is equal to TD upon TE. So RPM of E is equal to ND into TD upon TE. ND is what? 8000 upon 3 into TD is how much? 15 divided by T is how much? 40. Okay. So this will come out to be 8000 into 15 divided by 3 into 40. So it comes out to be 1000 RPM again. Okay, so what will be the RPM of E? It will be 1000 RPM. But as you can see, A has only 40 teeth. A has 20 teeth. E has 40 teeth, but they are both still rotating at the same RPM. It is because of this compounding. Okay, and if you are smart enough, you will see that C, D and E are in a simple gear train. So we can directly ignore D and find out the RPM of E using C only. How can we? This is completely right. Okay, this is completely right method. But if you want to do it a little fast, how can you do this? Because C, D and E are in a simple gear train. See, they are in a simple gear train. So we can do like RPM of E upon RPM of C is number of teeth of C upon number of teeth of E. So RPM of E becomes NC into TC upon TE, which is how much? NC is 4000 upon 3 into TC, number of teeth on C is 30 and number of teeth on E is how much? 40. So this gets cancelled. 10, 100, you get 1000. Okay, so you got the same answer, but in this case we just skip this one step. But no problem, you can go with the longer method. It is better to go with the longer method because it is definitely correct. You might make a mistake whether or not it is in a simple gear train or not. So this is the best method to do this sum.